Hello everyone. In today's lecture, let us have a brief discussion on the architecture of PIC16F877. Why normally we prefer microcontroller? PIC16F877 is a microcontroller, and why do we prefer microcontrollers? Because the size is very small, the cost is low, bit manipulation can be done, timing problems will not be there in microcontrollers, and reliability is also good, and varieties are available. Moreover, the code is highly secure. These are the reasons why microcontrollers are being preferred rather than microprocessors. These are the different applications where microcontrollers are being used. We use microcontrollers in our day-to-day life. And this is a common difference between a microprocessor and a microcontroller. If you see here, in a microprocessor, we have a CPU, that is central processing unit. All the memories, IOs, timers, and everything is outside of the CPU. Yes, in a microcontroller, if you see, all these components are inbuilt inside the processor. That is the difference between the microprocessor and a microcontroller. Coming to the features of PIC16F877, it's a 8-bit microcontroller. It is a 40-pin IC. It has a flash memory type. It has a RISC architecture. The instruction set is very less. It has only 35 single word instructions. Then it follows Harvard architecture. That is, in a Harvard architecture, the program memory and the instruction data memory will be different. It has separate program memory and data memory. It improves the speed, thereby the efficiency of the system. This is the overall architecture of PIC16F877. So if you see the architecture here, we have the ALU here. This is the ALU. This is the part where the operation is being done. The main section here, we have the main section. This is the part where the operation is being done. So if you see the ALU, normally ALU, it receives two input, and one input always will be from the W register. Another input will be through marks, and it could be from any other devices as well as from the instruction register, right? So based on the instruction, it will use through a mux, they will be receiving the instruction from any one of the inputs. Then here, whenever an arithmetic operation has been completed, the status register will be updated and the result will be returned in the file select register or the working register. And this is how this operation takes place, right? And other than this, it has two memories. One is the flash memory and another one is the RAM file register. That is, this is again a RAM memory, random access memory, right? These registers are used for program memories and data memories. So this is a special feature of a microcontroller. And then it has a program counter, and here we have a stack. If you see here we will be getting 8-bit address, and wherein it is incremented to 13-bit, and this adds one more bit here, and then finally 7 bits is used to. So already this 7 bits we have discussed in the addressing modes also. This is how the instruction is being fetched. So from the memory, the program counter will define which is the next instruction to be executed. From the memory, that instruction will be given to the instruction register, and from the instruction register through the multiplexer, it will reach the ALU. And we have the instruction decoder. The instruction decoder is used to decode the instructions, as well as it generates control signals. And here we have the timing and control signal generations. Here we have the crystal oscillators, we have the power up timers, we have the watchdog timers. So all these timers and clocks are available in this part. So this is the ALU part, this is the memory part, this is the timer parts, right? Timer in the sense clock and minor instructions being given. Other than this, PIC16F877 has It's a microcontroller. So IO ports, serial ports, all these things are inbuilt in PIC micros, normally a microcontroller, right? So similarly, PIC also has ports. IO ports are available in PIC, right? So altogether 1, 2, 3, 4, 5 IO ports are there. Totally 33 IO pins will be available with PIC16F877, and this 33 pins are splitted into 5 ports. Port A, which is 6-bit, port B, C and D are 8 bits, and port E is 3 bits. Other than this, other peripherals available with PIC16F877 are timer 0, timer 1, timer 2. Then it has ADC. Then it has a CCP and a memory EEPROM and serial cables. So this is altogether the architecture of PIC16F877. And the different buses available are address bus, data bus and control bus. So address bus, it is used to carry the address. Data bus, it carries data which will be normally bidirectional. Address buses will be unidirectional. And control bus is a group of conducting wires which is used to generate control signals or timing signals in order to synchronize the operation. Next, the different parts available is oscillator. Here pin number 13 and 14 are used as oscillator pins. Then we have the power up timers. The power up timer allows the voltage of the PIC to rise to an acceptable level before operating. Then we have the oscillator startup timer. The oscillator startup timer ensures that the device only operates when the oscillator generates a stable clock frequency. Then next is power on reset. Power on reset is a circuit that provides a predictable regulated voltage to the microcontroller with the initial application of power. All these are related with the timing and the accuracy. Then we have the watchdog timer. It's a hardware timer in the PIC which constantly reset by the software that will cause the PIC to reset. Here, if any of the any devices or any parts go to sleep mode, then this watchdog timer will be keeping on watching in it and it will generate wake signals. Then brownout reset. Brownout reset is a circuit that monitors the VDD level during operation by comparing it to a fixed threshold value. Then we have the in-circuit debugger also, which is a hardware device connected between PC and the target microcontroller test system and is used to debug real-time applications faster and easier. Then we have the low voltage programming, which allows the PIC flash MCUs to be programmed using the operating voltage of the device. So then we have the registers. We have two temporary registers are available, W register and special function registers, file select registers. These are the two temporary registers which is being commonly used. Other than this, we have the special function registers. The status register, the port register and trace registers are special function registers. And here we have the port registers. And other than that, we have the serial communication protocol peripherals, USART, SPI protocol, serial peripheral interface protocol, and I2C bus protocol. Then we have the three different types of timers in PIC16F877, which we'll be discussing in detail in the forthcoming videos. So two 8-bit timers and one 16-bit timers are available with PIC. And this is for your assessment. Thank you.